Hello dear aspirants and Life Science Academy. Today we're talking about the vision. So what is your vision? In this session, we have to discussing about the visual transaction. How you have to visualize how you have to visualize things. You have to visualize things because of your eyes, because your eyes. So your eyes is responsible for your vision and in your eyes, under your eyes, a specialized thing is present, which is retina. So in the retina, there is presence of two things. And what is the two things? One thing is rod cell, and another thing is your cone cell. In this lecture, we have to talking about the rod cell. If the rod cell is present here, this is working in dim light. Working in dim light. You can say signal transduction start in the dim light. And if we want to starting the cone cell is working under the bright light condition. Bright light. In this session, we have to discussing about the visual transaction under your retina. So let's start with the transduction. First of all, you have to know what is your consequence behind your vision. So if I have visual, I have visualized some things, or you can say all the things. So I have visualized. I have visualized something. What is something? As your wish. Friends, if we're talking about signal transduction pathway in vertebrates eye, here we have a nucleotide, cyclic nucleotide. You can say cyclic nucleotide gated ion channels. Like olfactory, in olfactory receptor, there is also a regulator which is a nucleotide gated ion channel. Here also a nucleotide gated ion channels, but here a nucleotide, a cyclic nucleotide is cyclic GMP rather than cyclic AMP. So here is presence of cyclic nucleotide gated ion channel and which is open in turn response to cyclic GMP, not the cyclic AMP. So we have cyclic GMP in particular signaling. So we have a structure of rod cell, So the rod cell photoreceptor is consisting of two things. And what is the two things? It consists of outer outer cell membrane, outer segment, you can say outer segment and inner segment. If we're talking about outer segment, in outer segment there is presence of disc. There is presence of disc of photoreceptive membrane. Lots of enfolding is present in the outer segment for the capturing the, or you can say trapping the light. In the inner segment, there is the inner segment, the plasma membrane. Here its photoreceptive membrane is present, not the plasma membrane is present in the outer segment. And a third thing, which is a cell body. As usual, two cell structure. And in the cell body, there is presence of also nucleus and a synaptic region. And a synaptic region is also present in this region. So this is the synaptic region. This is the nucleus. This is the cell body. This is the plasma membrane, which is situated in the inner segment of rod photoreceptor cell. There is lots of disc present, and in disc there is presence of the receptor. For what? For the light. So this receptor is what type? This receptor is a GPCR type. The receptor is what type? This receptor is a GPCR type. So as I can say that in the photoreceptor cell, usually what happened? Usually when signal transduction is initiated, its main, or you can say its main ultimate function is what to do? Its main function is to that it is depolarizes the membrane. But in case of vertebrate rod photoreceptor cell, there is not presence of depolarization here. Rather than depolarization, here is a hyperpolarization occur. Here is occurring hyperpolarization. So in turn, it results, you can say, inhibiting the release of neurotransmitter. What is that particular release? Is that particular neurotransmitter which is released from the synaptic region in case of hyperpolarization? So this will be glutamate. Glutamate is releasing as usual, or you can say as in normal condition, but in dim light. This glutamate is inhibited, or you can say not released from that particular synaptic region. So this is the overview behind that photoreceptor induction via the GPCR signaling. If we're talking about its structure, so as you all know friends, as I can initially that here is a outer segment which is light sensitive. So light sensitive is outer segment. In the outer segment, there presence of cation channels which is open in dark condition. Or its rhodopsin. Rhodopsin is what? Rhodopsin is the GPCR. Here is also a inactive in condition. So this is the dark condition, or you can say dark condition. You can say if the bright light, here we can say not bright light, here is dim light. So in the dim light, what happened? So previously you have to know what is normal in condition. So synaptic region similar to neuron in neuron transmitter. In normal condition, neurotransmitter is released from that particular axon terminal. High rate of transmitter is released from that particular region. But in case of dim light, what happened? In case of dim light, if the light is come on the photons and come on the receptor, photons is coming on the receptor. So rhodopsin is a receptor which is activated, and if the rhodopsin is activated, cation channels getting closed. Cation channel getting closed in this condition, and cell membrane is hyperpolarized rather than depolarization. In case of dim light, what happened in rod cell? Here, rod cell is depolarized rather than depolarized. In normal condition, depolarization is occurring. So the neurotransmitter is releasing in higher rate. But in case of dim light, there is presence of hyperpolarized cell. In the hyperpolarized condition, the rate of neurotransmitter releasing is low, or you can say inhibited. Why? Because there is cation channels is closed. And what is the cation channel significance? If the cation channels is open in condition, so what we can say, in this condition sodium is entering into the cytosol, but here cation channels is open. So as a result, as a result, potassium is more as compared to normal. As a result, what we can say, cell is hyperpolarized. Cell is hyperpolarized in condition. So this is the concept of how your vision, or you can say how your retina is working against the dim light or in the light condition. So if the photons is coming on the rhodopsin molecule, on the rhodopsin is a receptor. In this condition, cation cell is getting closed, and as a result, or you can say in turn, cell is depolarized rather than cell is hyperpolarized rather than depolarized. So low rate of transmission, release of neurotransmitter is occurring. So neurotransmitter releasing is inhibited. And why this inhibited? So we have a flow diagram for that. Suppose we have a plasma membrane. So this is the plasma membrane of photoreceptor, rod photoreceptor cell. So this is the photoreceptor, and this is the photon. And this photon getting excited to this receptor. As a result, alpha, gamma, beta. So this alpha is getting active now, and this beta gamma is dissociated from that. So what happened in the plasma membrane region? There is presence of guanylyl cyclase enzyme. This guanylyl cyclase enzyme breaking GTP into cyclic AMP. But here, as you all know friends, that cyclic AMP gated ion channels is closed. But here, cyclic AMP gated gated channels now closed rather than open. Why? Because of cyclic AMP concentration is very low in response to light condition. Now, cyclic AMP gated cation channel is now closed. As a result, what happened? As a result, cell getting hyperpolarized condition. So, if the hyperpolarized condition, there is no release of neurotransmitter. There is opposite working. Normally, how is working? There is depolarization, but in case of dim light, there is hyperpolarization is occur because of in the outer segment of photoreceptor cell, there presence of lots of disc, and in disc membrane there presence of cyclic nucleotide gated cation channels is present, and this cation channels is closed rather than open in dim light. So this is the concept behind your vision in dim light. Thank you friends. We'll meet in next lecture soon.